Hello, welcome to Picture Me Coding. My name is Erik. With me today is Mike Moll, my co-host. Hello, Mike.
Hey there.
Mike, you are heading out on a trip soon, I think. Yeah, you're going out of town?
I am. Road trip to go visit my father in Indiana.
So you can be our Indiana correspondent for the duration you're out there.
That's right. Get some viewpoints from real Americans.
Have you been listening to any music in preparation for your road trip out to Indiana?
Not in preparation for my road trip, but I have been listening to a fair amount of music. I think the album that I keep coming back to recently is the new Mitski album.
Mitski.
I don't know if you're familiar with her at all, but I discovered her in, I guess, 2016. She came out with this album called Puberty 2, which I really liked. And then a couple years later, another really good album called Be the Cowboy. Last year, she came out with an album that was kind of more synth pop oriented. I wasn't super crazy about it, but she has a new album out called The Land is Inhospitable and So Are We, which I really like. It's definitely quieter, more mellow. Reminds me a little bit of that Ways Blood album from last year that you were listening to.
That's a weird one. I still don't know how to feel about it. I've been listening to this German band called Bees Made Honey in the Vein Tree. I keep having to look up the name because I keep forgetting it. The album is called Aion. And when I first started listening to it, it reminded me of maybe Flight of the Birds. The description that I read of them was that they have crushing doom riffs.
Yeah. I listened to it a couple of times after you pointed it to me as well. And there are some crushing doom riffs, but there's also a bit of, I don't know what I would think of as like prog metal.
Yeah, that's a good description. There's so the word for psychedelic has been used in descriptions of them. Psychedelic doom riffs. It just kind of makes me want to float away on the lazy river of these mental space vibes.
Yeah, I get that vibe too. Although I sort of, when listening to it, was yearning for a little bit more of the drony doom sort of thing that you get from Sleep, or my personal favorites, Monolord.
Yeah, there's this thing that happens with where it's like they're building, and that's it. Whereas when you listen to Sleep, it's like they're building, and then blammo, they explode your brain with something 45 minutes into the track.
Yeah. There are some very long tracks on that album too. I think the last track is like 20 minutes, right?
Yeah. I like it though. I keep listening to it. I had a story I wanted to tell you today. So in 2018, I went to the Kubernetes conference, KubeCon. And as part of the conference, we got free access to the Space Needle and the Chihuly Museum over there, which is gorgeous, and the Pop Culture Museum. And we got to go open the Space Needle at night, and it was all free. It was pretty cool. And I was waiting in line to get on the Space Needle elevator. There was this long line. It snaked around the building, and then it went through the gift shop with these glass walls. And these two guys are behind me in line, and I started talking to them. And at first, as I was listening to them, I noticed that they were complaining a lot. They're complaining about the food. They were complaining about having to wait in line. These guys had nice watches on, and I thought, wow, they're used to being given like private car service and very nice meals wherever they go. Well, it turned out that they were sales people from Oracle, and they were at KubeCon, as part of their jobs to sell. And as soon as I found out they were sales guys from Oracle at KubeCon, I was like, wow, were people receptive to your message? I kind of like laughed a little bit, and they were like, no. I got the sense they were not treated well at KubeCon. They were friendly, but yeah, I just don't think KubeCon was the crowd for them. Anyway, so we finally got on the elevator to the Space Needle, and it's glass-walled elevator, and it shoots you way up into the sky over Seattle. You can see at night, you can see the lights everywhere. You could see the blank spots where Puget Sound is, where all the trees are around University of Washington. And this is all engineers in the elevator. Somebody jokingly asked the elevator operator, "Where's Jeff Bezos's house?" I was like, and I pointed behind me to the Oracle guys. I said, "These guys probably know. He's their customer." And one of the guys goes, "Don't you read the tech news? He's not our customer anymore." I was like, wow. I was a little put in my place. Obviously, this is 2018. I didn't read the news that he was talking about. Anyway, so after I got home, I was curious what he was talking about. I looked it up, and I read these blog posts from Amazon, from Werner Vogels, the CTO of Amazon. And he was talking about how they were transitioning all of Amazon databases off of Oracle databases to Amazon stuff like DynamoDB, AWS, or RDS, like all AWS. They're dogfooding all of their own stuff.
Their internal stuff. So they're still offering it as an RDS option, just not using it internally.
Yeah, right. So like if you work at Amazon and you need to store something in a database, no longer following, I think it was 2020, they finally shut them off. After that, or 2019, somewhere in there, you would not be using Oracle, whereas before that they were using Oracle. And this kind of blew me away. I can't imagine working for a massive company like that and having, this a proclamation from on high, you will stop using this database and you'll move everything to these other databases. It just seems like a Sisyphusian effort. And I actually found an article from Werner Vogels. Actually, no, it was from someone else who was at like someone who does like engineering blogging for Amazon. And he said, we migrated 75 petabytes of internal data stored in nearly 7,500 Oracle databases to multiple AWS database services. Another quote from that, more than 100 teams in Amazon's consumer business participated in this migration effort. Just seems like a monumental effort.
Wow, that's a lot of pizzas.
A lot of pizzas. So I was interested in this because that seems like that's a hard thing to do. It seems hard to me.
I would think it would be. I mean, there's got to be a lot of interrelated stuff there too. So it probably wasn't just something where they could all do things independently.
I can't even, I just can't imagine this. I guess it made me think though about this problem. Maybe a problem is even too strong of a term. It just made me think about what it means to move to another system. I don't know if you're okay with me using the word second system in this area.
I'm okay with it. I think I want to avoid, or not necessarily avoid, but make clear the distinction as related to Fred Brooks's famous second system effect.
Yeah, I think you got to cover that. Can you help us with that? And by the way, I think I've always heard of it as second system syndrome. And I also thought that if you and I were going to start a band, that'd be our band name, Second System Syndrome.
Yeah, probably a prog metal doom band.
That sounds great. So can you give us a description of Fred Brooks and Second System Effect?
So the idea is roughly that, you start off as a designer and architect of computer systems. We'll restrict ourselves to software here. And you build your first thing, and you tend to be relatively conservative because you want something that works, and you don't want to introduce things that you are unsure about. So you build something that's fairly parsimonious for your first system, but it works. It's functional. It's robust. But along the way, you keep thinking, I wish I had time to add this feature, or I wish I had time to do this particular uh, approach. And then you reach a point where you're going to build your second system,
Hmm.
and you think, okay, now that I am starting from scratch and I have a little bit of experience, I'm going to take all those bells and whistles that I left out the first time, and I'm going to add them to this second system.
Mm-hmm.
And the effect is that second systems tend to be over engineered.
Because you're trying to solve all your problems you had in the first system.
Well, not even necessarily solve the problems, but you are adding those things that you left out in the first go round to be cautious or prudent. Now you think you have more time, so you add them in. And I think the example that Brooks gives is um, actually a computer system, a hardware computer system, where when they built the second system, they added a whole bunch of new uh, machine level operations, and they were fancy, but a very large subset of them never got used. And so, you have this system that's fancy, but is really over engineered for what people want to use it for.
Hmm. So the question I have then is, if we just talk about moving from first system to second system, well, second system, not even necessarily first system, but if we just talk about retiring a system, retiring a massive software application, or in AWS's cases, moving from one database system to another, they don't always have to have this problem, right? Is that the objection you're raising?
Yeah, I don't think that's necessarily a situation where you're making huge architectural changes. I mean, you might be, like, if you're going from a relational database to a NoSQL database, that might be a significant architectural change. But to me, that feels more like it's still a massive problem, or a massive undertaking, but it's not something where you are trying to rebuild the system in such a way to add new features that you left out the first time.
Mm-hmm. Well, I think it just sounds so daunting to me, so hard to imagine taking a massive system and rewriting it, rebuilding it, or migrating it to something else. And so I got really curious, what makes people in our field decide to throw away a working system and build a whole new one? And there are all kinds of blog posts out there of large tech companies where they say, we had this system, it was working, and we decided to move on to some completely new system. Um, you know, there's a lot of these that come out in the Rust world, and so there's a lot of my examples are from there. But because people decide to rewrite stuff in Rust, and this is not meant to be evangelism for that, but Dropbox, they rewrote their core system, which syncs files in Rust. Mozilla, they invented Rust in order to rewrite their browser Firefox in Rust. Discord, they switched from Go to Rust. Now, not about, I mean, Rust is a common example. I'm sure there are other examples. I started reading these things like, why is it that people, what are the justifications that people give when they talk about moving from one system to another? And the Dropbox example is very good because they talk about why you wouldn't want to throw away an old working system and replace it, considerations you'd want to have before you want to do that. I started really wondering, though, what are the patterns here? Have you ever worked on a large system that you had to replace?
Not, not, not totally. No, I've had situations where we had to switch databases in sort of a smaller way, like what you were talking about with Amazon.
Hmm.
But I don't have a personal situation in my past where we started over from scratch with a new system.
Do
I
you,
I think I've seen it done. Back in the early days, there was there were pretty big differences in computer hardware coming out. So, like, back in the '90s, let's say, people were introducing like massively parallel systems,
hmm,
and
mhm.
uh, there was this uh, there was this sort of tendency to say, hey, we're going to have to make pretty significant changes to our algorithms to run our new finite element code on this
Mm,
thing. How about we just start from scratch and write it in C instead of Fortran or things, something like that.
hmm
Um, but from my perspective, most of the things that I've seen changed over the years have been kind of stepwise evolutions.
hmm Interesting. I'd be curious what you would say are the reasons why people would give to move away from a system to a new one. I did want to, before I get to that though, the Dropbox article is really interesting. And they quote Jeff Spolsky, who has this pretty famous blog post from 20
Joel.
years. Joel, sorry, not Jeff. I was thinking of, I was thinking of his buddy at Stack Overflow. Joel Spolsky. He has this blog post from 20 years ago where he calls rewriting code from scratch the single worst strategic mistake any software company can make. And he makes this argument that the code that you have, it may be ugly, but that's because it was solving a lot of problems that were discovered over time. So you're throwing away the vetted code, the battle tested code. You're starting over from scratch and you're not advancing your product in the meantime. He gives 3 reasons why people usually decide to do this. He says it's an architectural problem, first of all. That's the reason they give. Code is badly architected. Second is it's inefficient. They want it to be faster. And the third is they find the code to be ugly. Now, this blog post is pretty interesting. And there are critiques in there that I find that resonate with me. Like when he says programmers always want to throw away things and start over. That seems to be pretty accurate. But but when I read these other posts from AWS or Dropbox or whoever, those reasons that Joel gives are not often the reasons that they're giving. They're usually talking about how they have bugs in production that are really hard for them to find and replace. It's hard to ship. It can be hard to deploy. It's hard to test it. The one that Joel mentions that does come up a lot is it's too slow. So Dropbox moving to Rust to go faster and Discord moving from Go to Rust to drop latencies. That's a speed thing. But one that comes up over and over again is it's really hard to maintain this system. And so people decide to rewrite it so that they have something easier to have people contribute to. The AWS case from Oracle was it's really hard to maintain infrastructure wise, and it's also extremely expensive. Do you have any sense for why engineers like us would argue to rewrite or throw away systems and build a second system?
Well, I think there's, certain motivators that, like you say, latencies and performance is one. There was the somewhat well-known case back in the fail whale days when Twitter moved all of its code slowly from Ruby on Rails to Java, I think, something JVM based.
Mm.
Um, so there are probably are cases where it's just this system is not performing the way it needs to perform, and making the architectural changes that we need to make it performant is not a incremental thing. So we probably should just start from scratch and do it the right way.
Mm.
Um, I think there's also technological trends. We talked about this a little bit in one of our previous episodes, but there was a big movement in the 80s and 90s to move things into object-oriented languages.
Mm-hmm.
So I did, experience some rewrites at that point in time where people were just taking old code and putting it into C++ because that was the thing to do.
Mm-hmm.
I think there are probably, this maintenance thing. We've encountered this IRS system. What's it
Oh,
called?
yeah. Yeah. IMF, Individual Master File System. It was first written in 1961. It's still
Yeah.
running.
Yeah, it seems to still be in use. I'm sure there's a lot of people who would like to rewrite that, but there's this anecdote about it being 200,000 lines of assembly code.
I don't want
And
that job.
yeah, it's probably very difficult to read the assembly code, figure out what it's doing, and cast that into some higher level language.
But they are doing that. The article that we read, they are trying to do that. There's a government program to do that.
Yeah, I just can imagine that it's very time consuming and tedious. I mean, it's what's your line about code is harder to read than it is to write?
I don't think I can take credit for that.
Yeah,
It's like an inversion of Donald Knuth.
You've said that. You've said that to me a few times, though, and I think this is kind of an extreme case of that, where the code is probably, even for people who are reasonably familiar with that variation of assembly language, it's probably very difficult to read. And just the process of reading through it and then duplicating the functionality in some other language is almost like an archaeological process rather than an engineering process.
Yeah, that is a really interesting example, because the first pass that they had for rewriting this IRS program, which has been running continuously since 1961, now they run it on emulators so that they can continue to run this same application, this individual master file application. It's 200,000 lines of assembly from what we read. There was someone who wrote a program to transcode, I don't know the right word there, but to turn the assembly into Java. And so then they would have Java. And the problem with that was the Java looks like assembly. And their primary complaint with this individual master file application, software application, nobody can maintain the thing. They can't find people to contribute to it. They're pretty sure it works because it's been working for 40 years, but they can't build modern stuff on top. Like, they want APIs and other things. And they can't have anybody contribute to it. So the next effort is we're going to rewrite it in Java, but then you got to figure out what are all the inputs and outputs and what is the actual behavior and have we copied over the behavior? Again, it just seems extremely difficult, like a very hard project.
Yeah, I wonder if there's some sort of metric about how difficult it is to take one type of code and render it into a different language. I mean, it seems like in any rewrite, the spec that you start with is essentially the original code. But it seems like it would be much easier to do a rewrite from, say, Ruby on Rails to Java than it would be to do from, some mainframe assembly language into Java or C or Rust.
Yeah, I mean, at the very least, you've got expectations of the mentality of a developer in 1961 versus our expectations here in 2023. That's got to be pretty different. You gave the Twitter example. Do you remember why they argued they were moving away from Rails to Java and Scala too, I think, right?
Yeah, I don't know the details of what languages they use, but I know it was JVM based. I don't actually know, and to me it seems like there had to be more than just language and system issues. I don't. If I had something written in Ruby on Rails, I don't think I would necessarily think, hey, if I just render this into Java, it's going to be better. It seems like there had to be also some architectural changes made in the process of doing that, but I don't think I've ever read the details of them.
What do you think makes these types of transitions to second systems? And again, they could be third, fourth, fifth, whatever, but we'll call it second system. It's the next thing. What makes it difficult?
Well, I think it's just what's difficult is what makes software difficult. It's essentially the same thing as writing a system from scratch. And I guess the only benefit that you have in doing a second system is that you have a first system to use as a guideline, at least in terms of the functionality. So maybe there's a little bit less effort involved in requirements gathering when you're trying to build a new system. But everything else that you do in building a second system is the same as building something from scratch. You have all the new testing that you need to do, and all the new. There probably are some. You have to look closely at the qualities that you're trying to get out of the new system. Like if the original system is too slow in terms of latency, what are you going to do for the new system to get rid of that problem?
Mm-hmm.
So it's a significant architectural effort.
I wonder if Fred Brooks and the second system effect that you brought up at the beginning, where he's got this big warning sign that he's written a book about, which is be wary if you're making a second system that you might fall under this spell where you want to pack features in there, and that's probably a mistake. I wonder if that makes that mistake less likely to occur.
Which part?
Well, the fact that the fact that his description of second system effect is a well-known phenomenon. If I were building a second system, I would think, I better not make the mistake Fred Brooks told us about.
Yeah, there's probably a little bit of that, but I guess one has to wonder how much of the general lore of computer programming, does a 23-year-old who's just starting their career know about that?
Mm-hmm.
Know about something that Brooks wrote about originally and when 40 years ago.
So I want to go back to this thing about what makes it hard to build a second system. And you're talking about you have to test it. You're starting over from scratch. It's like building a first system, but you've got a template already. You look at the reason why people build second systems. They complain it's too slow. It's hard to add contributors. It costs too much. The first system, it's too buggy. It's too large. All of these features, or most of them, seem like they would contribute to the difficulty of building a second system. If it's really hard to add contributors and to know what the system does, then it should also be pretty hard to build the second system and know you're duplicating the behavior of the first, right? Maybe I'm out in a weird zone here. Like, I guess another way to say this is the reasons why I want to build a second system are also the difficulties. If I didn't have those difficulties, I probably wouldn't want to even build a second system. Maybe this is a tautology. Go ahead, sorry.
I think that, so I think you can sort of contrast building a second system with evolving an existing system. So, all software changes. It probably has some life cycle, but during that life cycle, it's evolving in various ways. You add features, you optimize parts of it, you perhaps you do some refactoring to split it into pieces or something. But the difference between that and a true second system is that it's always starting from what you have. So there's this sort of contingency, like you see in biological evolution, where the changes that you're making are starting from a certain point and are just incrementally evolving that thing. Whereas with the second system, you're basically throwing all that away and kind of creating new DNA, which you hope has the same, phenotype to carry.
Is it convergent evolution? Is that when two different species evolve the same feature independently? I can't remember what that's called.
Could be. I'd have to look that up. But yeah, so we've seen this in small cases and work that we've done in the past. Like we've taken prototypes that were built in like MATLAB and turned them into Python code.
Mm-hmm.
And you still have to make sure that the new stuff is producing the same answers.
Mm-hmm.
we came up with this term concordance in one of our jobs to to make sure that the numbers coming out of the back end were still the same as what they were before. But um, that's a case where you're using the original thing as a pattern, but you are not actually changing small parts of the original system and evolving it. You're really starting over from scratch and just trying to make sure that you get the same function at the end.
Hmm. I guess I wonder if building a second system is kind of like waving a white flag in the face of the first system. It's like, well, I give up. You win. You know, it's too complex. I can't add people to contribute to it. It's too slow. I can't solve the problems. And if that's the case, that's kind of daunting to me that we might have a tendency in our field to build things that become unmanageable over time. What if that's the natural state of software, that it's constantly evolving into something that you will have to throw away someday?
This may be cynical, but I tend to think that's probably the case for the vast majority of systems.
Oh, but
Um,
that is okay. Okay,
I mean,
is that true?
it's to a certain extent, it's just entropy. I hate to use entropy metaphors because these are not physical systems and really
Hmm.
not necessarily subject to thermodynamics. But
Hmm.
um, I think there is sort of this tendency for everything to get messier, um, and it's hard to go back. There's nothing that I know of, at least, where you can sort of cleanly specify what the thing is supposed to do. And, so when you're doing a rewrite, you kind of have to rely on the first system as as your template for what you want the second system to do. So I think any system, you start off, you produce something and you get some acceptance testing around that, and you say, okay, this does what we wanted it to do, and then you start to evolve it. But I think at that point you sort of lose the context of the problem you were originally trying to solve.
Hmm.
And I don't know. As I say, I think it's a cynical view, but I do think every product, every system in its life cycle is going to eventually evolve into something that becomes too complex for its creators to understand.
That is amazing. That is an amazing thing to imagine. If it is inevitable that you build a software application, whatever it does, as you contribute to it over time, it will become a thing that nobody can understand fully. And the only way to get your arms around certain problems that may occur or add contributors is to start over from scratch. I mean, if that's okay, now we can't just sit here and say, yeah, that's true. All this is inevitable for software applications. But if that happens, and it happens a lot, that seems like another indicator that there's something weird about what we do when we write software. Because this is probably not true for other things that people build in the world.
Also, though, for a system to reach a point where entropy makes it unmanageable, it also has to be successful to a certain extent. So it has to have a long enough life cycle
Hmm.
that it goes through enough changes to be to evolve to that point. So I think
Okay.
I think I heard this quote recently, and this does relate. I'll eventually explain why, but um, it had something to do with the use of petroleum as energy, and some Saudi uh, some Saudi prince or somebody in that industry. That he was asked, would we ever run out of oil? And his response was something to the effect of, the Stone Age did not end because we ran out of stones. Um, and so I think his point being that, we're probably, before we run out of oil, we are probably going to replace the oil with better things.
So there will be a
And
technological advancement. It's not just that the raw material will stop.
yeah, and so, there are systems which probably evolve to a certain point and they start to get messy and unmaintainable. But before they reach that point where people throw up their hands and say, we need to rewrite this, they get supplanted by something which is just better.
Hmm.
And so I don't necessarily think that it's inevitable that every software project reaches that point. But I do think it's, if a project is sufficiently successful and there's not something that comes along to disrupt it, then it probably will eventually reach that point.
Wow. So there's a couple conditions that you're setting here. One, it has to be successful. And success, I think, in this case, isn't necessarily like, oh, it's a product and we're selling a ton of it. Success in this case probably means for a software application, it gets used a lot, whether that's an internal thing inside a company or externally in the world or whatever. So success, is that a fair definition of success for a software application? It's used extensively.
Used extensively, or has an exceptionally long life cycle, like this thing at the IRS. It's been around for, it's probably not, um, from a modern viewpoint, it's not beautiful software, but it's been successful in the sense that nobody has been able to easily replace it with something else.
Hmm. Okay. So that's
You know,
another way of thinking about its success.
yeah. Or, something like the original telephone switching system, I've always heard was a pretty beautiful piece of software that had a very long life cycle, still around to a certain extent today. Um, those things are successful, in the sense that they've they've performed what they were intended to do for a long life cycle.
Mm-hmm. So success is the first part. Second part you mentioned is there's some, you use the word entropy, which seems fine to me. Uh, uh, and I'm not an expert, so that's probably why it seems fine to me. But it seems fine to talk about entropy as a result of a lot of contributors over the lifespan of a particular application or system. And as you have different contributors coming in and changing the thing, it does become harder to reason about it in total, I guess. I still am really concerned that this may be an inevitable fate for anything that we might build. I mean, I guess another way to say it is, if you told me from the beginning that anything I build, if it's successful, will eventually be replaced, thrown away, and that's a like even like a mark of its success, I would kind of think, well, what's the point? And B, I would think, well, maybe we could just keep evolving it in order to prevent ourselves from having these problems. Maybe I can keep it so that it's not hard to add contributors. Maybe I could keep it from growing in complexity until it's completely non-understandable, et cetera. But maybe
I,
that's naive young developers, not young, but early career developers' response to this.
I think it's interesting to think about this in sort of an extreme way, or maybe reductio ad absurdum, perhaps. So imagine that you're building a software system and it does something which is generally regarded as useful. Now think about why it is or is not going to still be in use 1,000 years from now.
Mm, mm,
So what is it? As far as we know, no software system is going to last 1,000 years, except maybe the software that they put on the Voyager, because it's no longer possible to modify. But you know, my assumption would be there's probably nothing that is being built right now that will still be in common use 1,000 years from now.
Mm-hmm.
So is it just that the hardware, somebody invents quantum computers and everything that we've written so far is useless?
Mm-hmm.
Or is it some other factor that causes it to be replaced, or maybe the thing that it does no longer is interesting to people 50 years from now?
Yeah, that's fair. I mean, your hardware example is a good example because if I wrote a program 20 years ago, I might not expect that it would run for 20 years in the face of advances in parallel computing or other things. You already mentioned parallel computing as a great example. So software is just a thing that doesn't live that long. Let's actually finish with this question. You work for the IRS. Let's say you're the CTO of the IRS, and they come to you and they say, Mike, we need to rebuild our massive 200,000 lines of assembly. What are you going to do? What are you going to build that in? And oh, by the way, if you do a great job, your software will last for 60 years.
Wow.
Can you imagine your 60-year software application?
So first I'm going to ask if we can rewrite it in Rust, of course.
Yes, the answer is yes. I've never heard of Rust. If I run the IRS, I've never heard of it. You can do whatever you want. Mike, I trust you.
Yeah, it's an interesting problem. I'm actually kind of intrigued by it. I do not totally understand why it's been so intractable. I mean, 200,000 lines of assembly language code is a lot of assembly language code. And, this is assembly language from, I assume, like an IBM mainframe of the era of the 60s, I guess.
Maybe written by Grace Hopper herself.
So, there's a task, as I said, archaeological task there of just figuring out this assembly language and reading through it bit by bit to figure out what it does. But it's still curious to me that has proved so intractable.
Mm-hmm.
I would think that people understand what this thing does. I assume they must have some sense of not necessarily the specifics of how the software is operating, but they know what it's supposed to accomplish, right?
Mm-hmm.
So I'm kind of curious as to why there hasn't been a more successful effort to do that.
I find your opening a little provocative as well, although I do like the idea we'll rewrite it in Rust. But if you say to me, we're going to write this massively important and long-running application, and I want it to run, let's say 10 years, not even 60 years, 10 years, the first brick wall that I run into of questioning, do I want to use any open source software? This is a thing that has to be built over the next 10 years. I usually use a lot of open source software. Am I comfortable with that in this case? I want this thing to be at least 10 years. I have to rebuild and build it. Maybe I have a CI server. I can rebuild the thing every day. And if it fails, I can just go in there and fix it. Open source. Would we want to build very long-term stuff on top of the open source software ecosystem? What do you think?
Well, that's probably one real benefit of having 200,000 lines of assembly code is that there's probably almost no concern about updating your dependencies. But yeah, I mean, if you're going to rebuild it today, and you would probably want to use open source, but with something so sensitive, you would definitely have to be super careful about supply chain issues.
Yeah, I mean, I wasn't even thinking security. I was just thinking, can I build this thing in 10 years? How many of these libraries that I load as dependencies are going to need to be updated every? I mean, even if we're probably deploying it on Linux servers, that's got to be updated every so often. Rust is an open source language that would have to be updated every so often. Yeah, it's not an easy problem to solve. But the flip side of the problem speaks to what I think of as my expectation that the stuff that I write will maybe run for about 5 years with some periodic updates, and that's about it. Like, that doesn't seem a very high ambition to me. You know? I don't know. Wouldn't it be nice to build something that lasts?
I remember reading somewhere in the past that, a typical life cycle for projects that actually ship is around 10 years.
Hmm.
And so, I figure if I put something into production and it lasts 10 years, I've done okay. But it does make you wonder why there isn't something like, go back to the 1,000-year uh, scenario that we were talking about before. Why isn't there something to capture better what the software is supposed to do?
Hmm.
Because you kind of have to assume there's going to be a rewrite, or maybe you assume that somebody else comes up with a better way of, a better mousetrap, and so they don't need to know how your system worked. But it does make me wonder why there's not something that sort of assists in the process of rebuilding new systems, to make it easier to figure out what the function was supposed to be.
Is that, I'm going to go out on a limb here and probably make a mistake, but is there something with the Entscheidungs problem in there?
Mm, that seems a little bit of a stretch to me,
Hmm.
but back in the good old days, we did this requirements gathering stuff and tried to write documents and put together databases of requirements and stuff like that. But even so, it's not really a very formal way to describe what the thing is supposed to do.
Hmm.
And you know, like if you were writing a system today and you wanted to, uh, send that off to an alien culture and have them build something similar, how would you describe it to them?
Hmm. Interesting. Maybe TLA plus. Well, I find this topic to be very large, and I guess I'm kind of haunted by the idea that what we've talked about here, that second systems are inevitable. If they are inevitable, I feel like I should really pay attention to that when I'm building my first system. And maybe it's just foolish to imagine that I can. Maybe second system is a marker of success of a first system. I don't know. I'm a little bummed.
Yeah, it's a little bit depressing to realize that something that is not actually a physical object is going to become obsolete. But it does, it happens over and over again. So it may not be inevitable, but so far the evidence indicates that it's pretty common.
Oof. All right, we're going to leave you with the last word on that one. This is Picture Me Coding. My name is Erik Aker. I have my good friend Mike Mull with me, bumming you out, bumming me out. And we'll see you next time.
See you next time.
Bye-bye.